The Japanese government made a desperate decision. On August 22, 2025, they released a video designed to intentionally terrify 37 million of their own citizens. If the event it simulated ever happens, Tokyo dies. Right now, the largest metropolitan area on Earth lives just 60 miles from one of the planet's most dangerous volcanoes. They work, commute, and exist in the shadow of a single mountain. One icon, and that icon has been showing signs of breaking apart for over a decade. In August of 2025, the government's own AI models predicted that an eruption would blanket the city in a city-killing layer of ash, paralyzing the entire nation within hours. Not a warning, not a possibility, a certainty. And here's the part that is so important. So many of you who watch these documentaries and find this information critical forget to subscribe. We are a small team, and every single subscription makes it possible to continue producing this work. It's an emergency button for our channel. Please take 1 second to hit it. Your support is not just appreciated, it is essential. Let's begin. The government did something no one was prepared for. They showed the world a vision of the end. An unannounced full-scale eruption of Mount Fuji, rendered not in artistic speculation, but by cold, calculating artificial intelligence. The videos showed a gray mushroom cloud consuming the horizon. They showed the high rises of Shibuya district, a global symbol of modernity, disappearing beneath a blanket of falling ash. Trains derailed. Power grids failed. Midday turned to absolute darkness. It wasn't a movie. It was a forecast. This was not a drill. It was a calculated act of psychological shock, released by the Tokyo Metropolitan Government and the Cabinet Office of Japan just days before the country's newly designated Volcanic Disaster Preparedness Day. The message was brutal and clear. The moment may arrive without any warning. They were telling their people that the quiet, snow-capped peak they see on postcards and in art is not a friend. It is a time bomb. And the clock has been ticking for 318 years. The real question is, was the government's AI simulation just a scare tactic? Or was it an admission that they already know the mountain is breaking, and that Tokyo simply isn't ready for what comes next? You see, this story is not about what might happen. It's about the damage that has already been done, the cracks that are already there. The mountain has already started to fail, and almost no one is talking about it. It's clear a lot of you are deeply engaged with this, and I want to know your thoughts. Do you think a government using AI to simulate an apocalypse is a necessary warning, or an irresponsible act of fear-mongering? Let me know your gut reaction in the comments below. Mount Fuji was never supposed to be perfect. The iconic, symmetrical cone is a geological illusion, a mask hiding a deeply unstable interior. Volcanologists don't see a symbol of tranquility. They see an active stratovolcano sitting at a volatile triple junction of tectonic plates. The Amurian, the Okhotsk, and the Philippine Sea, plates all grind against each other directly beneath this mountain. It is a nexus of immense geological stress. Fuji has erupted roughly 180 times in the last 5,600 years. That's an average of one significant eruption every 30 to 50 years. A normal, predictable rhythm for a volcano of its size and type. But the mountain has now been silent for over 3 centuries. The last major event, the Hay eruption, ended in early 1708. That silence is not a sign of peace. In volcanology, it is a sign of building pressure. The longer a stratovolcano holds its breath, the more violently it tends to exhale. The pressure that should have been released in 6 or 7 smaller eruptions over the last 300 years is still down there. Contained, concentrated, waiting, and the container is starting to crack. The most visible evidence is a massive scar on the mountain's western face. It has a name, the Osawa Failure. In English, the Great Saw Cut Collapse. And it is exactly what it sounds like. It is a colossal, actively collapsing gorge tearing the mountain apart from the top down. This is not a small fissure. It is 2.1 kilometers long, up to 500 meters wide, and 150 meters deep. It's a canyon being carved into the volcano by its own structural failure. Over its 1,000-year history, the Osawa Failure has already shed 75 million cubic meters of soil and rock. To put that in terms that mean something, that is enough material to fill the Tokyo Dome, a 55,000-seat stadium, 60 times over. Gone. Completely gone. And the collapse is accelerating. Every single year, the Osawa Failure sheds up to 15 million cubic meters of debris, a constant, unstoppable landslide of rock and sand pouring down the mountain's flank. The problem is so severe, so relentless, that the Japanese government had to create a dedicated agency just to deal with it. The Mount Fuji Sabo Office, a branch of the Ministry of Land and Infrastructure, has a single job: build check dams and concrete barriers to catch the pieces of the mountain before they bury the roads and towns downstream. They are in a perpetual war against the mountain's own decay, building structures to contain a national icon that is actively falling apart. This is a monster hiding in plain sight, a crack so large it is visible from space. And it's not the only one. There's another, more recent, and in some ways more frightening fracture. One that tells a story about the mountain's hidden connection to Japan's other great geological threat. Earthquakes. If you're finding this information valuable, please take a moment to like this video and consider sharing it with your family. Understanding these risks isn't about fear, it's about awareness. And sharing this documentary helps get this critical information out to more people who need to see it. On March 11th, 2011, the ground off the coast of Japan ruptured. The 9.0 magnitude Tohoku megathrust earthquake unleashed a wave of devastation that the world watched in horror. It was one of the most powerful earthquakes ever recorded, shifting the entire island of Honshu by 8 feet and triggering a tsunami that led to a nuclear catastrophe. But 4 days later, on March 15th, something else happened. Something that was largely lost in the headlines of the ongoing nuclear crisis. A magnitude 6.4 earthquake struck directly beneath the southern flank of Mount Fuji. Not a distant tremor, not a gentle aftershock, a direct hit. The earthquake's hypocenter was just above the volcano's magma chamber. The jolt was so violent that it tore a literal crack into the surface of the mountain. Renowned volcanologist Shigeru Aramaki with the Yamanashi Institute of Environmental Sciences investigated the site. What he found was a fracture 20 meters long and several centimeters wide. A fresh wound ripped into the sacred mountain by the seismic energy of the Great Quake hundreds of miles away. The mountain had been physically broken by the earthquake. It was a clear, undeniable sign that seismic events could compromise Fuji's structural integrity. Panic began to spread among local communities. Citizens and journalists tried to find the crack, to see the damage for themselves. And then it vanished. High winds on the exposed slope quickly shifted sand and loose pebbles over the fracture, burying it from sight. The evidence was hidden. But the weakness it revealed was now part of the mountain's new reality. The 2011 earthquake did more than just tear a scar into the surface. It fundamentally changed the plumbing system deep inside the volcano. A change that scientists wouldn't discover for another 5 years. This is where the story moves from visible cracks to invisible forces, deep beneath the ground. In 2016, a team of geophysicists led by Koki Aizawa, then at the University of Tokyo, published a stunning paper in the journal Geology. They had been mapping the subsurface of Mount Fuji, not with drills or seismometers, but by measuring its electrical conductivity. Different materials, like solid rock, water, and magma, conduct electricity differently. By sending currents into the ground and measuring the resistance, you can build a 3D model of what's happening deep underground. What they found was a ghost in the machine, a long, linear anomaly cutting directly beneath the volcano. They called it a mechanically weak zone. It was a fault line, a fracture system deep within the volcano that nobody knew existed. And it was not dormant. The 2011 earthquake, they concluded, had pressurized the magma chamber below Fuji. That pressure needed to go somewhere. It found the weak zone. Aizawa's team discovered that magmatic gases, like helium and carbon dioxide, were rising up from the depths of the earth, moving through this newfound fault line, and leaking into the groundwater network around the mountain. The pressure cooker was venting. Let me read you Koki Aizawa's own words. We found a mechanically weak zone that is apparently susceptible to remote seismic triggering. We were really surprised and worried about an eruption, because the hypocenter was located above the magma chamber. The scientist who discovered the hidden crack was worried. The system wasn't just cracked, it was active. The gases proved that there was a direct pathway from the magma chamber, the heart of the volcano, to the surface. A pathway that was likely widened and activated by the force of the 2011 quake. So now you have the full picture. A massive, crumbling gorge on the outside, a 20-meter fracture torn open by an earthquake, and a hidden fault system underneath, acting as a superhighway for high-pressure gas escaping from the magma itself. The mountain is structurally compromised from the inside out. And all of this brings us back to the government's AI simulation. Because the greatest threat from a cracked and overpressurized Mount Fuji isn't a river of lava flowing towards Tokyo. Lava from Fuji has never traveled that far, and it likely never will. The true catastrophe, the one that keeps disaster planners at the Cabinet Office of Japan awake at night, is something far more insidious. Ash, I'm going to remind you one more time. I know, this might be the second or even third time you're hearing this, but it's unbelievably important. So many people, millions of people, watch these documentaries to the very end and get immense value from them. But they forget to click subscribe. Each subscription is a vote of confidence that allows us to tackle these huge research-intensive topics. If you believe this work matters, please prove it with one click. It's the single most effective way to support what we do. Thank you. Now, back to the city-ending ash. To understand the scale of what Tokyo faces, we have to look back to the last time this happened. The Hei eruption of 1707. That event was also triggered by an earthquake. On October 28, 1707, one of the largest quakes in Japanese history, the 8.7 magnitude Hei earthquake, ruptured the Nankai Trough Fault Zone south of Japan. For 49 days, the ground shook with aftershocks. Then, on December 16th, the built-up stress found its release point. A new crater, the Heikok, blew open on the southeastern flank of Mount Fuji. For 2 weeks, the volcano ejected a colossal plume of ash and pumice. The sky went dark. Ash fell like snow on the city of Edo, the historical name for Tokyo, located 100 kilometers away. The government of the ruling shogun, Tokugawa Tsunayoshi, was completely overwhelmed. Crops failed across the entire region, leading to widespread famine. Rivers were choked with sediment, causing massive floods for years afterward. It was a national catastrophe that took decades to recover from. That was 1707. The government's working group on wide-area ashfall countermeasures, chaired by volcanologist Toshitsugu Fuji, has calculated what a modern Hei-scale eruption would do. The numbers are staggering. The 2011 Tohoku tsunami generated about 50 million cubic meters of disaster debris. A full-scale Fuji eruption is projected to dump 490 million cubic meters of volcanic ash on the greater Tokyo area alone. That is nearly 10 times the volume of all the debris from the 2011 tsunami. 10 times the shattered buildings, the ruined cars, the entire physical record of a region's destruction. Except this time, it would all fall from the sky. Volcanic ash is not like ash from a fireplace. It is tephra, a mixture of pulverized rock, minerals, and jagged shards of volcanic glass. It's abrasive, corrosive, and when it gets wet, it conducts electricity. It is uniquely engineered by nature to destroy a modern civilization. The government's crisis models are built around a few terrifyingly simple thresholds. The first is the 10-centimeter rule. Once ash accumulates to a depth of just 10 centimeters or about 4 inches on roads and train tracks, the city stops. Entirely, cars lose traction and stall as the fine glassy particles clog air filters and engines. Trains derail as the ash packs onto the rails, reducing friction to near zero. Above-ground power lines, when dampened by even light rain, will short-circuit from the conductive ash, causing widespread blackouts. At 10 centimeters, the world's largest metropolitan economy, a nexus of 37 million people, becomes completely paralyzed. No movement, no power, a megacity frozen in place. But it gets worse. The next number is the 30-centimeter rule. 30 centimeters, just under a foot of ash. At this depth, a new threat emerges. Many older residential buildings in Tokyo and the surrounding prefectures are still made of wood. Dry ash is heavy, but manageable. The moment it rains, that ash absorbs water, becoming exponentially heavier. At 30 centimeters deep, the waterlogged ash becomes a thick, concrete-like slurry, and its weight will exceed the structural load capacity of standard wooden roofs. They will start to collapse. People would be crushed inside their own homes. The government's own disaster plan states that once ashfall is forecast to reach this level in a given area, immediate evacuation becomes mandatory. The only problem is, how do you evacuate millions of people from a city where no cars or trains can move? This brings us to the most dangerous and least understood part of the entire threat, a chilling concept that some experts are calling the pavement paradox. And it is the reason why Tokyo in the 21st century is ironically more vulnerable to ash than Edo was in the 18th century. When ash from the 1707 eruption fell on Edo, it landed on a city of dirt roads, gardens, and open soil. Much of the material could be plowed into the ground, or was eventually absorbed into the landscape. But modern Tokyo is different. It is a city of asphalt and concrete, an impermeable surface stretching for hundreds of square miles. Professor Naoya Sekiya from the University of Tokyo Center for Integrated Disaster Information Research has warned about this for years. When 490 million cubic meters of fine glassy ash falls on Tokyo today, it will have nowhere to go. It will sit on top of the asphalt. And then, when the first rain comes, it will mix with the water to form a dense, non-porous sludge. This sludge will flow directly into the city's storm drains. Tokyo's municipal drainage system is a modern engineering marvel, designed to handle extreme rainfall from typhoons. It was never designed to handle a cement-like slurry of volcanic glass. The drains will clog almost immediately. The entire system will fail. The mixture of ash and water will back up, flooding streets not just with water, but with a thick, abrasive mud that will then begin to harden. It would be like pouring fast, setting concrete into the city's arteries. The cleanup would be a logistical nightmare of a scale humanity has never faced. You cannot simply hose it off. You cannot plow it to the side of the road. It has to be physically broken up, scraped off every single surface, collected, and transported out of the city. But where do you put 490 million cubic meters of toxic material? That's enough to fill a space 1 kilometer square to a height of nearly 500 meters. There is no landfill large enough, no disposal site ready to handle that volume. And how do you even begin the cleanup when every road is impassable, and every piece of heavy machinery has had its engine destroyed by the same ash it's supposed to be clearing? Experts like Toshitsugu Fuji warn that a full cleanup of the metropolitan area could take years, or even decades. For a significant period of time, large parts of the world's most populous city would become uninhabitable. A modern Pompeii, buried not in an instant, but choked out slowly by a gray concrete like cancer. Some parts of the government are trying to prepare. In May of 2026, Kyoto Ward, a central district in Tokyo with a daytime population of 900,000 people, officially began restructuring its local disaster plans. They started mapping out prioritized ash removal routes to keep access open for hospitals and emergency facilities. It's a start. But it also highlights the terrifying scale of the problem. One ward, with a fraction of the city's population, is struggling to figure out how to clear a few critical streets. Now multiply that problem across the entire 14,000 square kilometer expanse of the greater Tokyo area. The equation simply does not compute. The government's AI simulation in August 2025 was not a work of fiction. It was an admission of failure. An admission that the very infrastructure that makes Tokyo a modern marvel, its pavement, its power grid, its transportation network, is the same infrastructure that makes it uniquely vulnerable to the one threat it can never control. The mountain's silence is not peace. It is pressure building. The cracks are not ancient history. They are active warnings. The Osawa Failure is shedding 15 million cubic meters of the mountain every single year, a constant reminder of its fragility. The 2011 crack proved that Fuji is not immune to the seismic convulsions of the archipelago it sits on. And the hidden fault below, venting magmatic gas, proves the engine is still running. The government showed its people a vision of the apocalypse because the data suggests the apocalypse is a genuine possibility. They are trying to shock a complacent public into understanding a truth that volcanologists have known for decades. That Mount Fuji is not a postcard. It is a damaged, overpressurized, and dangerously quiet geological weapon pointed directly at the heart of one of the world's great civilizations. The third straw in Las Vegas was drilled to reach water. The dikes in the Netherlands were built to hold back the sea. These are engineering problems with engineering solutions. But you cannot engineer a solution to a 3,776-meter tall volcano that has decided its 300-year silence is over. All you can do is watch, wait, and try to prepare for a catastrophe that, by the government's own admission, could arrive without any warning at all. This isn't a cautionary tale about a city in danger. It is something more complex. It's the story of how 37 million people learned to live beside a god, and the uncomfortable moment when that god showed them the scars it had been hiding. The AI model has made its prediction. The scientists have issued their warnings. The mountain has shown its cracks. The only question left is what happens when the next one appears. The final fissure. The one that doesn't just scar the surface, but runs